So you were supposed to work in your groups with this, so I'm just going to ask you one group or one table. Listen, please. One table at a time to give some of your responses. So let's start with these, you guys right here. Tell us 2 differences that you found between these 2 drawings.
Row number 1 is curved, and then row 2 is straight.
Is straight. Okay, that's good. Do you have another difference?
The one that is curved would be longer than the straight one?
Yes, it would be longer because it's curved. Yes, very good. Okay, up front, across the front of the room, tell us 2 similarities you found between them. One of you, yes, one of the 4 of you that's up there. Somebody speak up. Doesn't matter who. Okay.
One of the similarities is like both of them have like an equation as if they're in a linear function, kind of.
Okay.
Like yesterday we learned about the whole like curvy thing.
Right.
We really don't really know how that works.
Right.
But like in row 2 is like a linear equation.
Yes, it is. Very good.
Yeah.
And then, is there another similarity between the 2? That was very good. They're both roads.
Yeah,
That's true. They both have trees. Okay. So, anybody have anything else different from those that you want to share? Functions. One's a one would be a relation unless you can write it as a sine wave. But the way it's written, it wouldn't be a function, right? Okay, looking at the next question, what comes to your mind when you see the word linear? Ladies, you here in the middle. What comes to your mind when you see the word linear? Okay. Straight line, a graph, a function. Do you realize that the word linear has the word line in it? The word linear has the word line in it. That's another way to help you remember. Okay, the table over to the left by the door here. What is the function negative 2x plus 10 linear?
Yes, because it has a consistent pattern.
Right.
Or formula to make it linear.
Right, it does. It meets the pattern of your slope-intercept form, right? So it has a constant slope, and it has a y-intercept. All right, very good. Drawing. So I can move this up. Okay, which of the following points, whoops, you can see my answers. There's another copy. Oh well, I guess we'll go with it, unless I can erase it. Which of the following points, so let's see. Over here on the back left, which of the points are on the graph? 2, 6, 0, 10. Oops. So this one, 2, 6, 0, 10, and 6, negative 2. Now you can do this one of 2 ways. You can actually draw the graph and look to see if which points are on the line, or you can plug those numbers in and calculate the results and figure it out from there. So if you actually drew the line, oh, it won't let me see that. If you actually drew the line, then you can look and see which points are on it, or you can substitute the value 2 in for x. You get negative 2 times 2 is negative 4, plus 10 is 6, and that works. So that one is a point on the graph. So either way, you could do that. Right? Okay, this next group, haven't asked you guys yet. Laura has a $10 lunch allowance for the week at her. It's worded funny. Lunch at her school costs $2. Can this situation be represented by this function?
Yeah.
It can. So explain how you know.
Because like she starts at 10, so that's like the y-intercept.
Yes.
And then she like loses 2 every day.
Every time she eats lunch, she loses 2. Yes. Very good. So be sure you document your thinking. All right. So coming back around. All right, I'll just open this one up to anybody because we've been to each group. Tell me a situation that you can think of that can be modeled by a linear function. Oh, yes. Okay.
So, it's like a story. So, this is the situation. So, this is a random school, and every 2 minutes, 10 more children walk into the cafeteria.
Okay. Every 2 minutes, 10 more children walk into the cafeteria. It's a constant rate. It's not the rate's not changing or fluctuating. That is a linear situation. Thank you. Very good. Any others? Somebody else share what you found? Don't be shy. We have to get comfortable with each other and talk so I know what's going on inside your heads.
A tank is getting drained by 2 gallons every 2 minutes.
Okay. Very good. So there's a tank of water. It's being drained by 2 gallons every 2 minutes. Any others that you can think of? Yes.
So, a heartbeat beats 60 times per minute.
Okay. Yes. Very good. As long as you don't start running, right?
Yeah.
Yes, ma'am.
Bo has $20. She wants to save $5 every week.
Okay. So she starts with 20. That's the y-intercept. I'm going to save $5 every week. Those are all great examples. Thank you for sharing. So now we're going to take some notes on this paper, this linear review paper. So for the learning target for this paper, for this set of notes, I can graph and write the equation of a line by using formulas. And we're going to use the formulas that you learned in Algebra 1. That one I'm going to let you hold on to because I'm already taking up 2 today, and I'm a little overwhelmed with all the papers on my desk. So just put that one in your notebooks. Sometime, probably the day you're taking your test. Did you get the message I sent to you today? We'll have a quiz on Friday, and then we're going to grade it and go over it in class so that you know what you missed. And then we're going to have a test on, this is B-Day, so when the day we come back, you're off Monday. When we come back on Tuesday, we'll be in A-Day, so your test will be Wednesday. Now, I don't have much control of this because we have to have a major grade in for the progress reports by the end of next week, so I have to have time to grade it. We will actually finish this unit at the end of next week, so you will have your district unit test the next week. And I apologize for you having 2 tests so close together, but there's no other way to get the grades into the grade book, and I can't rush us through to get you ready for the unit test by Wednesday. So we'll just finish and take the test, the actual one for the district over the whole unit the next week. But the one on next Wednesday will just be over the things we've covered so far. The unit test will cover everything. And I'll keep it short. Well, all the tests will be short because they have to be finished in 45 minutes. So the unit tests do because everybody else in the district just gets 45 minutes in class. So I will keep your other tests limited to 45 minutes so you'll get in the habit of, actually remembering you have to keep working and moving on and not getting distracted. But it'll be a short test just so I can have a major grade. I would have preferred to have given you a project. There just wasn't one to associate with this new curriculum that they put here at the beginning of the 6 weeks. Okay, so the rest of this paper you see in the box here are the formulas that you've had in Algebra 1. So you have your slope-intercept form, and that's the y equals mx plus b. Then you had your point slope form. in this form, be sure to note that the y and the x are variables. You do not replace the y and the x with numbers or a point. You have to have the y and the x for it to be an equation. The x1 and the y1 points, this one, oh, is it too, yeah, it's too heavy. Never mind. Where's my undo? Oh, there it is. So the x1 and the y1, that is the data from your point. So this, the x1 here matches here, and the y1 here matches here. Okay. So those will be substituted with numbers from the point. The slope, you will put in the slope that you've calculated or that you've been given, actually. You'll put that in for the m. But the x and the y, the two variables, have to stay in. And then finally, you may be given 2 points, in which case you use the slope formula. I want you to keep remembering, I'm going to keep telling you this. This is delta y over delta x. Delta is a math symbol that we use to mean change. The change in y over the change in x gives you the slope. So it's just another way for you to think about it, to help you remember it, to help your brain store it somewhere in your brain that's easy to get to. So those are things from Algebra 1. We're reviewing the formulas. So what we're going to do now is we're going to look at an example. Oh, actually there are 2 examples here. I've been doing that bottom one. All right. So we are given a graph, and we're told to use the graph to find the equation for this situation. It shows the cost to hire a plumber for X number of hours. Now, the first thing I want to point out to you is that you need to get in the habit of not just counting the grid marks. These are not actually on the crosshairs, so it's a little bit of a clue, but sometimes they are. So if you notice, this point here is not exactly where the 2 grid marks cross. But often, people will just look at this and go, oh, that's at 1, and we go up 1 and over 4 and say, okay, the slope is 1/4. But that has no relationship to this graph. You have to include looking at whatever the scale is. So actually, this is going not from 1 to 4, but from 1 to 3, because every 2 of those squares is 1 hour. And then as we count up, we need to use the values we were actually given for the y's, because otherwise we're guessing. We know from the graph it's a little above 300 and a little below 200, but if we aren't given the values, we don't know. So change in y over change in x. So 325 minus 165 here, and 3 minus 1, the change in x, gives us 160 over 2, or a slope value of 80. Now, this process that we're about to do is what you're going to be doing on your next activity that you're going to work with a partner. So just be sure you're getting notes or paying attention to this, because this is the same process that you will do. So you're going to start with the point slope form, and you can pick either one of those points to substitute in or plug into the formula. In this case, the point 1, 165 was chosen. Notice y minus, this is x1, y1, right? So the x1 goes with the x, and the y1 goes with the y. That makes it a little hard to see. So y minus 165, the y stays in the equation. 165 is the y1 value here. 80 is the slope. This is 80 is the slope, and x stays in the formula, and minus 1 is my x value from the point, is my x1 value. So on your paper, when it asks you for the point slope form, you're going to write it just like that. Then when it asks you to find the slope intercept form, you're going to show these steps in your work. So this is to find the slope intercept form. So the first thing we have to do is we have to distribute the 80. So we're going to multiply the 80 times the x and the 80 times the minus 1, and we get 80x minus 80. So then we have to add the 65 to both sides here. So we have a minus 80 plus 165, and that gives us an 85 for our slope-intercept. So this is our slope-intercept form of the equation that matches this data. Any questions up to this point? Yes. Yes, I have to sign you out, though, so you bring your badge back here. It's here. Make sure you go only 3 times, and if you go less than 3 times, you get 6 weeks. Yeah. Yeah. Okay, so now B says to interpret the meaning of the equation from part A in the context of the situation. So tell me, what does that equation mean? What is that equation giving us or telling us about the plumber? There's a fee cost of $85. And then what? What does the 80 tell us?
The amount of money it would cost to bring the work
Each hour. So we're going to have to pay him $80 every hour, and we're going to have to pay him $85 as a fee to even come out to the house. Okay? Everybody get that? Is that clear? Yeah. All right. The C part says that, the C part says, what is the plumber's minimum charge for a service call? So $85. Did anybody decide it was $165? Okay, this question is worded in such a way that it kind of depends on your interpretation. Yesterday, there was, people were starting to argue it's 85, no, it's 165. But here's the thing. Whichever answer you put, if you justify it, if your justification matches what you said, I will not count that wrong. Here's why. His minimum charge, his fee to come to your house is $85. But is he going to drive out to your house and you're going to hand him $85 and he's going to turn around and leave? No. He's going to work at least part of an hour, right? He's going to do something when he gets there. So the minimum you're going to pay is going to be $165 if you assume that he's going to do some work when he gets there. So if you put $85, it's not wrong, because I think the question meant to ask you what is the fee. But that isn't what the question said. So based on what the question said, if you decided the answer was $165, as long as you write your justification on your paper that there's a fee of $85 for coming out, and if he comes out and he does any work, you're going to pay at least 1 hour, you're probably not going to pay him any less than $165. So because the way the question was worded, you could have taken either perspective there, and as long as you justify that next to your answer, then I'm okay with that. Questions? So let's look at example 2. A recording studio. Oh, wait, I have to turn this off. A recording studio charges musicians an initial fee of $150 to record an album. Okay, what did they just tell us? They told it the initial fee is $150, and that's our y-intercept. So that's our B value. Okay. Then studio time costs an additional $35 per hour. What's the 35? The slope. So write an equation that gives the total cost. So we know that our equation is y equals, our slope is 35, and x represents our hours. and our y-intercept is 150. So now find the total cost of a recording of an album that takes 12 hours. What are we going to do with the 12? We're going to put that in place of the x. So we're going to calculate y equals 35 times 12 plus 150, which is equal to what? 350 plus 70 is 420 plus 150 is 570, yes. So the cost, you would write a whole sentence. The cost for 12 hours is $570. So any questions about this? All right. So I'm going to give you the instructions for this next piece so I can finish the recording for the people who are absent. And then I'll hand out the papers for you. So what I'm about to give you, you're going to work with a partner. So if there are an odd number of people at your table or around, then find, looks like it's all. So if one person from that table and one person from this table work together, everything else is an even number now. Yeah. So I'm going to give you 2 sheets of paper, partner 1 and partner 2. So you're going to write your name on whichever paper you get. You're going to work with your partner. You're each going to work the first problem. So problem 1 and problem 1. Now these problems are similar. They just have different number values. Once each of you works problem 1, then I want you to share your results, discuss how you did it, check each other's work, and make sure it's right. If you have questions or if you're stuck, then at any time you can ask each other or you can call me over for help. So you're given 2 points. You're going to graph those points and I guess draw the line since you have a graph. You're going to use the slope formula to find the slope. You're going to write it in slope-intercept form like what we just did. Then you're going to do those steps to convert it to, you're going to write it in point-slope form first, and then you're going to go through the steps to convert it to slope-intercept form. Now, here's where some responsibility on your part comes in. I didn't pre-assess you, so I don't know how well you know this or how rusty you are about doing this because you did it in Algebra 1. If you and your partner get through the first problem, this was easy, you remember it, you got it, then you don't have to do the other 2 on the front. If you're not sure or you struggled a little bit, maybe you need to practice another one. Maybe you need to practice all 3 of them. They're all 3 the same kind of problem with different values. So how many of the ones you do on the front is up to you based on what you need to do. I'm not trying to give you busy work just to give you busy work. This is practice and review just to make sure you remember what you did in Algebra 1. So on the front, you must do 1. You may do up to 3. The back, these 3 problems are real-world problems, and I want you to do all 3 of them. So the way this works, so let's look at this is partner 1. Yeah. So partner 1, you're given the data, but you're given the data in words. Yeah, I have to. They won't let me scan you back in. Okay. In case it didn't work, 10:36. So Jared started saving money. The first 2 months he saved $400. So your X is 2, your Y is 400. So your X1 is 2, your Y1 is 400. After 6 months he had saved $1,000. So your X2 is 6 and your Y2 is 1,000. So those are your points. Find the slope and interpret its meaning in terms of this situation. Write the equation in point-slope form So this is the same work that you're doing on the front, but it's with a real world problem. Then put it into slope-intercept form. So you're going to distribute the slope and then take the y2 value over. Then use your equation for part C to find out how much he saved after 14 months. And then find out how long it will take him to save $3,100. So what are you going to do with the 3,100? So for this one, you're going to have, nope, I'm in the wrong place. For this one, you're going to have 3,100 is equal to, and that's where you're going to, whatever equation you have from right here, this equation right here, you'll put the rest of the equation. And so you'll have something x plus or minus something, right? So in place of, for this one, the y is 3,100, and you're going to solve this one for x. So any questions about what you're supposed to do? Okay, so figure out who your partner is if you're working with somebody next to you or across from you, and I'm going to bring around those papers now.